So let's learn what are magic methods and how these magic methods work in Python. So what are magic methods? Magic methods in Python are methods that start and end with the underscore, double underscore. So these are all, whatever you see here, these are all magic methods. But those magic methods, you should not define your own magic methods. They are not meant to define. They are, yes, and so they are called implicitly. You don't have to call mostly manually. So that is why they are called magic methods. And we have seen one magic method which is new, and there is another. Sorry, we have seen init magic method. Init stands for initializer, and there are other magic methods like new, call. Okay, so let's say I'm defining a magic method. So I'm defining a class person. Okay, sorry, so define means which is a function. Yeah, person. Okay, so let's go with let's take an example. Let's go with we will see today inheritance as well as a magic methods. I'm defining a staff. Okay, and so each staff is having a something called a branch. Okay, yes, branch, which is by default, let's say Melbourne. Okay, and default branch and ID. There's a SID, staff ID. Okay, those are actually which is none. Okay, and there are some methods for the staff. Okay, which is like defined. Method, always methods take first argument as a self. So so what are some behavior, what are functionalities associated with staff? Let's imagine this is a university. Okay, so which is there is another attribute called is teaching. Okay, is teaching by default true. Okay, so which is there is a teaching staff or non-teaching staff. I'm actually defined is teaching. Okay? So if it is a teaching and there is another called a class called I'm defining, it inherits. Okay, it inherits staff teaching, and this is how we inherit. This is called we inheritance works. Okay, so we have a class, and within a parenthesis we specify that this is a derived class. These are called base classes. We separated by comma, we can specify any number of classes. So here I'm teaching teaching staff. Okay, teaching staff is inheriting from a staff. So here what I'm doing is teaching you. Okay, and you see all other are actually we will get all two remaining two attributes are inherited in a teaching staff, because I'm as a part of inheritance, even though I don't define SID and branch, they are inherit. Okay, and is teaching there we don't have to. Yeah, so is teaching, probably, we can put a none here, okay, or anything. So we are overriding. This is called overriding, okay. So we are overriding a variable that is a attribute inherited from staff, okay. So I'm defining another one called tutor, okay. So he is inherited from teaching. So this is a multi-level inheritance. Can you see? So there are different types of inheritance. If you can see, types of, so single inheritance and multiple inheritance, multi-level inheritance, and hybrid inheritance. Okay, this is a single or simple inheritance. What you see here, multi-level inheritance, which means a B inheriting from C, inheriting from B, B inheriting from A. Okay, so which is it is a multi-level inheritance. Okay, so we have A is a base class, and the B, which is a derived class of A, and C is derived class of B, and you can see that is what we have it. So two tutor, and here I can define a staff, default attributes that are okay. So thing is that when I define what is this magic method define, we have seen initializer, okay. When I type underscore underscore, you can see there init, delete attribute, call, dir, eq, format. These are all our magic methods. I'm defining init. What is init? Initializer. Okay. Initializer. Okay. This is called annotation. Okay. So this is not actually necessary. You can remove this or you can put this thing. That is a syntax in a Python tree added to annotate. Okay, so what it returns define. Okay, it is like a if without that also it will work. So here I have defined so this init method is a special method. It should not return anything. Okay, so it is initializer. So I'm for our understanding, I'm printing initializer, and self represents object itself, right? Self. And let me define a class also. Okay, so what is this class magic method? Okay, so you can see this thing, define init, and so when you have actually different inits, you have to super refers to the parent class. Okay, so we have to actually take we have to call a parent init method uh, explicitly. Okay, so if you don't define anything, let's do one thing. Okay, so I don't have any methods, so I have this tutor here. Okay, so let me actually execute this thing. How this init method works? How that init method works? That will be called as an initializer when you instantiate. What is instantiation? Process of creating instance is called instantiation. So when you instantiate an instance, that initializer will be called. Now let's do this thing. Here I'm creating a tutor. Let's say mark equal to tutor. Do you get it? This is I'm initializing. Okay, the creating instance. Okay, instance of tutor marquis. And if you run the thing, Python space new, and you see, okay, Python 3 space new, and do you see initializer? Okay, so where it is called? why on earth actually there is no unit in a tutor, there is no unit in a staff, but there is a unit in, sorry, there is no unit in tutor, there is no unit in teaching staff, but there is a unit in staff that is getting called. Can you see initializer? This refers to instance, why it is called a cell. Class is also a magic method. Class refers to the class. Okay, the class this particular method is bound to, on which it is defined. So can you see here, this is a staff. Class refers to staff. Can you see? But the object is object. Can you see object main dot tutor, which is object object or instance? I said they are interchangeable, which is a object means that it is a tutor object, which means that it is an instance of tutor. Do you get it? Got it? Okay. And that is what the inheritance is. So this init is a magic method that is will be called during the instance when you create an instance, and that is called initializer because it is used to initialize default attributes, okay, parameters. So since this teaching staff and tutor, they are actually inheriting whatever the methods or attributes they don't have, they are inherited from the parent class or a base class. Okay, so if I, yes, a class, this is a class is not a magic method here, magic attribute, which refers to the class on which this method belongs to. So I don't know that what, so I want to refer on which this method is actually defined. So if I wanted to refer, I can use a class. Okay, so you will see that in a moment. I have the same thing initializer, but if I execute this now, okay, so to differentiate, I'm using star star here. To differentiate, I'm using hash hash here. Okay, so if I run this thing, now what do you see here? Hash hash or star star? Yes. And do you see that star star is not getting executed? Okay. So tutor, so remember this is very much important concept. This is called a shadowing effect. Okay. So this is called method overriding. Okay. So since we defined init here, so what it does, it overrides the method which is defined in a parent class or a base class. Okay, so it is like a shadowing effect, so this actually shadows the same method that is defined in a parent class. Okay, so if you have the same method with the same name in a class, which takes a precedence over the same method that is available in a parent class. Is it clear? So yeah, same method. If same method is defined in a derived class, we call it as a method overriding because we are overriding the method in a parent. Okay. Yes. Yes, it overrides the teaching staff. Same method in a teaching staff. So that tutor method in a tutor that takes a precedence. And you see this, now you can see here, this class is a magic method, which is actually the magically refers to the class on which this method is defined. Now here it is printing teaching staff, right? Okay, do you see here it is a teaching staff. In the previous run it was referring to staff. Okay, so now just for us to avoid confusion, I use the hash here star. Okay, yes, on which class this method is actually defined. Okay, so but even though this is a method of teaching staff that is available on tutor through inheritance. Got it? So to understand, I can define a class print details self, okay, print method on, okay, method of, and format of. We have this, we can use that like that as well. We can use class, okay, got it. So self dot, okay. And so if I'm actually printing details such as a print branch format of self dot branch. How do you refer attribute? Self dot branch, not a branch, and staff ID, which is SI, okay, is teaching. That is what we have so far, right? We don't have any other attributes. So if I call this thing, I can call that method mark dot print details. So how can how I'm able to call print details even though that is not defined on a tutor? Because mark is a tutor instance. Got it? Do you get it? Mark is a tutor instance. So how I'm able to actually call this method on a mark instance? Because of inheritance. Since tutor is inheriting from teaching staff and teaching staff is inheriting from staff, so all methods of staff is available to teaching staff. All methods and attributes of a teaching staff are available to tutor. Okay, so just remove this teaching staff. Okay, so let's say that tutor is not inheriting from anywhere. So simply run python 3.new.ex and I get that attribute error. Tutor object has no attribute, print details. Is it complaining? Attribute error, tutor object has no attribute, print details. So this mark is a tutor instance and mark that print details. Mark is, let's say, is a tutor in some university X, and so we want to print details of that particular tutor. So I'm trying to print, so I don't have those print details. But what I can do, I can redefine, I can redefine this here in a tutor. But that is not actually good practice. Okay, that is not the best way to program. There is no code reusability, there is no modularity here. Okay, so if you go and redefine, there is no particular pattern approach, and so it becomes a bad code and your code smells. Okay, so what, instead of that, since tutor is a teaching staff and the teaching staff is a staff, so imagine where do we use inheritance when there is a is kind of a relationship. Okay, since tutor is a teaching staff is a staff, the one there is a is kind of relationship, there we can simply use inheritance. So I can use teaching staff. Since I use the teaching staff, you can see this tutor is inheriting from teaching staff. All methods of a teaching staff attributes are available to tutor. Since like a genes, we inherit from our parents. Okay, so it is inheriting all attributes from teaching staff. Okay, so that you see that you don't have to write all sorts of code, so you don't have to, you can reuse and you can do a lot of stuff with this. Okay, and and since teaching staff is a staff, teaching staff inherits all attributes methods from a staff. So consequently, all of the methods and attributes of a staff are available to tutor. So if I run this thing, okay, and now you see it is working. It is no longer complaining attribute error, print details are not available. You can see, what do you see here? The initializer. Okay, so initializer, where it is getting called. Now, this is what it is calling. Yeah, init is, what do you see? Do you see here? The initializer. Initializer is a magic method. Init is a magic method which will be called implicitly when you create instance. This init method of teaching staff is getting called since it actually overrides a method from a staff. Okay, and there we can see here in a print, okay, it is actually staff, a method from a teaching staff. Can you see here? Okay, and here, okay, this we have seen, we can see some difference here. And now what these magic methods, magic attributes work. Okay, so can you see methods print details? It shows that, okay, this method print details, okay, is inherited to tutor. Okay, so this is from the tutor. That is what it means, self.class. Do you get it? Okay, self.class refers to on which class, okay, which means that virtually this print details is inherited and available on a tutor, even though it is not defined there. So self.class refers to the tutor. Okay, which self.class always refers to, okay, yeah, class of the instance. Okay, the what is an instance is a mark, and self.class always refers to who is the class, who is the blueprint, what is the blueprint of this instance? Tutor. So that is what it is referring to, self.class. Okay, but underscore class, which refers to, okay, on which class that particular method is defined. Okay, the standalone class attribute. Okay, a variable. That is what we can see here. We can see here when we use the class, we can see here a staff. Okay, since it is defined on a staff. Okay, but whereas in this print statement, and we can see it as a teaching staff. Can you see? Okay, if I use self.class, okay, okay, if I use self.class, and here also I will see tutor. Do you get it? Yeah, even though this is a method of defined on teaching staff, okay, the self refers to this instance. Okay, so self.class always refers to the blueprint. Okay, who initialized that instance, okay, refers to self.class. And we can see the same thing, we can verify when I print the self. I will print, okay, so let's put a print statement, self, okay, and self. It doesn't matter in which class and which class that method is actually defined. Self always refers to this mark. Okay, so to verify that, before I print, okay, id of mark, okay, what I can do, and just put a print a mark. Okay, got it? Okay, so if I run this thing, should I clear this or keep this thing? Okay, so let's keep that and run this one. Now, do you see the print statement here? So since I'm initializing, first you will see the initializer, the tutor. Can you see, remember this ID? 10CF B6D0. Okay, so which is a self here. This is what here, this print statement, this is from here. Got it? Okay, the address of self. And when I print this ID of mark, which also refers the same, can you see? Got it? Okay, which refers the same. And when I print a self here in a print details, which also refers the same. Do you get it? Do you see this one? X 10 CF B6 D0. So this when I print that mark, by default it prints that class, okay, and that address, okay, which is kind of represents the ID, which represents a kind of address. So same thing, like as we discussed, Python sends that object as a attribute as a first argument. Okay, so by convention we actually name it as a self. So we don't have to pass that. By default, Python gives that, passes that the object in address of a reference of that object itself as a first argument here. So we can see it. Can you see the self, which refers to this object itself, which is actually passed by Python? So you may ask, is the self passed to just magic methods only? No, the self is given to all methods, just general methods and magic methods. Can you see here the print details also, the self, which refers to the object itself. So that we verified by putting the print statement here. The self, this print statement refers to this object. Can you see the same thing, which refers to the same object, idea of the mark and same object here. So, but when the print statement from here, the refers class, okay, to teaching staff. Whereas if you see the print statement here, it refers to self.class, always refers to the blueprint that created that instance. Whereas you can see that is the reason here tutor. But if you refer just a class, which refers to the actual class on which that method is defined, which is a staff. Okay, is it clear?